Hello everyone, my name is P. Kali Prasad and I am from CSCF. Uh, I am going to explain the how to execute the lex and YAG files. And this question I am going to share the question. Uh, the question is implement LALR parser using lex and YAG for the following grammar. The grammar is given here, and in this grammar we can find out the non-terminals and terminals. Non-terminals are E, T and F, which are given in the left hand side of the grammar, and we can easily find out them, but we need to find also terminals like plus, star, multiplication, we can call it anything, open parenthesis and closed parenthesis, and also number. These are the terminals in this grammar. And coming to the tokens, the terminals are directly converted into tokens with any external factor plus star open parenthesis number should be converted with some extra word like how can I tell you, some expressions. We can add it with some expressions like digit star or any number between 0 to 9, like that. We should have some number. Okay, we are going to execute this grammar using two files. One is lex file and one is YAG file. I have those files to share. Here, this is the lex program. In this program, it is converted into two parts. First part is the declaration part. Here we are just declaring nothing, like include y dot tab dot h, nothing more. And this is the second part. In this second part, this is the definition of the program. The main definition of the program is here from this which I selected. Now 0 to 9 indicates the number of digits from 0 to 9. How many digits we can change it anyways. Plus 0 to 9 plus. And here YY text is some, you can call it as string also. We are converting it into an integer and adding the value to the YY value. Here ATOI is converting the YY text to the integer, like TOI to integer. Return number, you can understand. Number token, number is like token number. It returns the token number, which token it is. And this is some slash n like new line, and is slash t to be ignored and return 0. Okay. YY text, the new line. When we see a new line, we should ignore. This is the code for slash n, and here is the dot. Other than the identified tokens that you have written in this, if you get any other tokens, like you just get written the first part of it. If you get any other tokens which you have written in this program, which you have not written in this program, it will return, simply return. It is a function of the dot. And this is the lex file, and there is another file, YAG file, which is here. In this we have three parts. First is, as usual, declaration, hash include stdio. In this we are going to print something, so we use this stdio, standard input outputting. And another thing is token number, we are going to indicate. And here is the main part. This is the definition of this program. Like, this is the grammar we are going to present here. Like you can see here, the grammar E derives E plus T, and this is the S means we are creating a new start state. because we are going to end. When the program ends, we need to print the tree, like the tree will end at a point, it is E, and we are giving it as new state and simply print it. This is a function of this line. And here you can, this is the production rule. You may get confused a little bit about this dollar symbol. It is nothing but the action of the production rule. It is going to represent you the action of the given production rule. The E represents, here you can see the E represents the double dollar symbol, and this is from the left hand side we are going to represent as double dollar, and in the right hand side number of elements, like E is one element, plus is another, T is third. We are going to give them a numbers, $1, $2, $3, like that, and we are represent the E as $1 and plus as usual, like it is a something, and T as S3 because it is the third item in this production rule, and we also have the T directly as a production rule, and we are going to give it as $1. Like this, the three rules are written in this production rules. Beside the of them, we are going to see the action of them, and this is the main part of the program. We are not going to see it in this backward program like which we have seen before. We only see it in the YAC program. Main program is third part is in here, not in this legs part. Here we are declaring the how to execute this program and printing it. This is error handling, print error. If there is an error, it will print, otherwise it won't be printed anything. We are just checking for the errors in the program by this print option, void error, you can see it. And I'm going to execute the code now with this both files. We should save both the files with a name called, like you can save it as parse.l and parse.l as the first file, lex file, and parse.y as the second file. First program will do the job of identifying the tokens, and second program will completely execute the program, and it will give you the final state of the parse tree. And I am going to save the two files as sample.l and sample.y, and you can execute this program in both command prompt or in Ubuntu, but I am going to do it in Ubuntu. I have already did it. Here is the output of the program. Yeah, I already executed it. Here you can see, get it, it will create a new file that you can return on it. You can, I will show you how to execute it also. First I am explaining how it has to be done. And sample.y, it will create a file .sample.y that I have already created, and I had already created the sample.l also. And the commands that you have to use to run this program is, first you have to write the lex and the file name. File name should be like sample.l. You should save the file with an extension of .l, and YAC file should be saved with an extension of .y. Here this, when you write the code like lex sample.l, it will run the code, and if it find an error, then will it be returned something here, or otherwise it will just return the something root, right? Again you can run the YAC file and there are no errors. Again you get this, and then you will gcc and lex.yy.ct. Here is where the Equivalent of the lex file is C converted into C language, like equivalent lex file equivalent to C is saved as lex.yy.c, and YAC file equivalent to C is saved as y.tab.c, and we are going to execute it, and we need to add an extension like minus hyphen y, and again you can, if there is no error in these two codes, then it will be written like this, and you can simply ask for output dot slash a dot out, then you should return the question, you need to give some input. 4 plus 3 star 5, that's 19, it returned, so the program is completely executed. And I'm going to show you this again, like get dit get it space sample dot. Okay, I'm going to create another file like var.l. When you press the enter button, you can see the screen is shifting. It's running a little bit slow. Yeah, here you can paste, write the code for lex program. I'm going to just simply copy paste it from the notepad, which I already have the code. Yeah, here, and save it, just save it, and then return to the command prompt again, like terminal, and again you need to create another file, get it space where, or you can change the name also, char.y, y for lex file, enter. Not found. Okay, I've written a wrong command. Get it, gedit space car.y, enter. Yeah, you can simply copy paste the program from here, and save it. Now that both programs are completely saved in the terminal, and now you are going to execute the program. You just check the commands that I should run. Yeah. Now first we should execute the lex file. Lex space what we saved, var.l, and now we are going to execute the yak file. So we are going to yak space -d space car.l, not l, y. Enter. No errors have been in this program, so it is not showing anything. And now we are going to execute both of them for checking the errors. Space -d space sample dot l. Oh, we have already done it. We don't need to do it. I'm just going to execute gcc space lex dot yy dot c space y dot tab dot c, and double. Yeah, no errors. Now we are going for the output. Here we need to give some input, like for example 6 plus, sorry, 6 plus 3 uh, into 8. Yeah, it is showing the result like 30, and if there is an error in the given input also, it will show the error. Like I will show you how it is to be done. Like if you give like 5 plus and again star into 8, it will give you a syntax error. You can see here error, syntax error. Uh, so that's it, how to execute this program. Thank you.